Hello everyone, and welcome to our calculus mini project. Today, Siti Zuhaira will be doing question 1, Vanessa Kong question 2, and Aina Adila on question 3. Sit back and enjoy our calculations. Question 1a. To sketch the graph for the bounded area, we first need to find the intersection points for the two given equations. Substituting x1 and x2, we get x1 to x1. Simplifying this equation, we get 2x(x1). 2. Expanding this equation, we get x2 for x1, 0. Solving this quadratic equation, we get x2 3 and x2. Substituting these values of x and ux. 1, we get y 3 ini 1 squared 3. Now we have the intersection points as 2 squared 3, 1 squared 3, and 2 squared 3, 1 squared 3. To sketch the graph for the bounded area, we need to plot these intersection points and the given equations on a graph and shade the region bounded by them. Question 1b. To calculate the area of region A, we need to integrate the function 2e plus u24 with respect to x, where I varies from the lower bound of x1 to the upper bound of x1 to the upper bound of 1, 2. This means that we are finding the area of the region between the two curves x1 and x1, 2, u2. The integration is done by substituting x1, 2, u2 in the function 2e plus y24, and then integrating with respect to u from the lower bound of y0 to the upper bound of y2. After performing the integration, we obtain the value of the integral as 18. Taking the absolute value of this answer, we get the area of region A as 18 square units. Question 2. Region Q is bounded by rotating xt. Question 2a. Sketch the graph for the volume of the solid by rotating the bounded of region Q. Based on this question, the worksheet shows an example of a quadratic equation. The equation is -4 equals to 6 minus 3y divided by plus 3a mi. Then plus 3y minus another 6 equals to 0i powered 2 plus 3i minus 10 equals to 0. The calculations also includes the quadratic formula, which is -b plus minus square be power 2 minus 4a and c, then divided by 2aea, where a, b, and c are coefficients of the quadratic equation. In this case, the quadratic formula is used to solve for I in the equation. By substituting the values, ei equals to 2 and I equals to -5 are the two solutions for the quadratic equation. Now, let's continue to question 2b. Prove the volume of Q is 31,556 pi over 15 by using method of disks. The given math problem involves finding the volume of a shape called Q using the method of disks. The calculation involves integrating a function over a range of values to find the total volume of the shape. The function to be integrated is derived from the equation Ri equals to 24 minus EU y minus 4 then equals to 28 minus I power 2 plus R minus 24 minus another 6, where 6 minus 3 equals to 3i plus 18. The integral is taken from -5 to 2, which represents the range of I values for the shape Q. The integral is simplified to yield the function viy equals to -65y power 3 divided by 3, then plus 54i power 2, then adding 460 ui. This function is then evaluated at I equals to 2 and I equals to 2 and e equals to -5 to find the values of the function at the endpoints of the range. The difference between these two values gives the volume of the shape Q. Substituting the values of I into the function uu divided with 31,556 pi over 15 and v divided by -5 equals to 0. Therefore, the volume of Q is 31,556 pi over 15 cubic units. For question number 3, sketch the video for the volume. Region B is bounded by rotating ei to the x-axis and the y-axis about the x-axis and the y-axis about the xe. We try to find x-intercept is when you hit 0. So x0, 2, 2, we can conclude it as xe4 when you 0. I-intercept, we can find it when x is 0. So 0, y, 2, 2. 0, I2, u2, we just take 1 because it is the same. So ya2 when x. Next, we move to the next question, 3b. Find the volume of B by using cylindrical method. We found the graph of the bonded region and the solid in 3a. Okay, we are rotating about a horizontal axis. This means that the area will be a function of I, and so our question will also need to write in xefey form. As we did in the ring selection, let's take a couple of looks at a typical cylinder. In this case, the function value in the distance between the edge of the cylinder and I-axis. As the answer for this question, show the cross-sectional area. The first cylinder will cut into the solid at u2, and so this is our limits of integration. So the volume of the solid is just like the shown answer. That is all from us, Group 1. Thank you for reviewing our mini project. We sincerely hope that our calculations are accurate, but if by chance they are not, we humbly ask for your forgiveness.